Green economic development. Community green economy strategies, resource efficiency and green purchasing, local production and utilization, waste stream management, green infrastructure. Community green economy strategies should focus on the main binding social economic constraints towards the attainment of community vision. It is meant to guide the country governments, the private sector, civil society, and other actors adopt development pathways with higher green growth, cleaner environment, and higher productivity relative to the business as usual growth scenario. It should aid communities transition to sustainable path in the following 5 thematic areas: resource efficiency and green purchasing. This encompasses all natural resources that are inputs to the economy, including physical resources and ecosystem services. Under the green economy scenario, more outputs will be realized with less natural resources, while the overall economic value will be increased through high total factor productivity or GDP to domestic material consumption ratio. Resource efficiency is applicable at different levels of the economy, including but not limited to the production supply chains. A green procurement or green purchasing policy is put in place to guide businesses when acquiring materials, supplies, and services, and selecting such products based on their impact on the environment and human health. Green procurement can apply to both products bought to run the business internally, example, office supplies and equipment, as well as for producing the goods and services of the business itself, example, materials used in business products. Green procurements are those that have a low environmental impact and are more sustainable in terms of the materials they are made from and the sourcing and manufacturing practices that make them. Green procurement also considers the immediate and future impacts of purchases through their consumption and eventual end-of-life stage. Green procurement policies embody the triple bottom line, a business framework for improving performance in all 3 areas: environmental, social, and financial. Local production and utilization. Production and consumption systems vary significantly across Europe. Food, energy, and mobility systems account for much of Europe's pressures on the environment and health, but are also a foundation for our well-being. Consumers can play a role in shifting consumption patterns, whereby reducing pressures linked to consumption. Local production for local consumption refers to efforts to consume agricultural and marine products produced in domestic regions within the region where they were produced. Local food systems significantly reduce the need for long-distance transportation, a major contributor to greenhouse gas emissions. When food travels shorter distance, there is a substantial decrease in carbon emissions, making these systems inherently more sustainable. By purchasing local grown foods, you help maintain farmland in your community. Local foods promote a safe food supply. On the other hand, local manufacturing can be more expensive due to the higher labor costs, transportation costs, and limited access to materials and suppliers. Lack of sufficient access to goods, facilities, and services is a concern expressed in many poor urban and rural communities. Utilizing local resources often provides personalized and tailored experiences. Local professionals possess intimate knowledge of the area, allowing them to offer customized services and advice that cater to specific needs and preferences. To improve physical access at the local level by optimizing and combining the use of local resources in the development, operation, and maintenance of community works through local level planning, increasing participation, targeting vulnerable groups, and promoting the use of local materials and technologies in project implementation. Utilizing local resources is essential for various reasons. It strengthens community bonds, preserves cultural heritage, stimulates the local economy, promotes sustainability, and offers personalized experiences. Non-governmental organizations and local community initiatives have the ability to carry out activities and projects in their communities with the help of human, material, technical, and financial resources. While it may seem easier to obtain resources from external sources, such as foreign governments and multinational companies, community contributions can actually be more beneficial in the long run. Mobilizing local resources not only provides the necessary skills and materials for community improvement projects, but also helps establish important relationships with individuals and institutions within the community, strengthening the NGO, the local community initiative presence. When you use local resources to support your NGO and local community initiatives projects, there are several benefits for both your organization and the local contributors. Sense of ownership. The more citizens, institutions, and business contribute their time and resources to activities that benefit their communities, the more they feel a sense of ownership and pride in their accomplishments. This leads to a positive development of their communities, making it a better place to live. Building social capital. Social capital pertains to the worth of social networks and the greater willingness of individuals and organizations to extend help to each other due to these connections. Non-governmental organizations and local community initiatives can establish enduring relationships with other institutions and organizations by seeking support from the local community. This relationship enhances the social capital within the community and establish a stronger foundation for future endeavors. Sustainability. To ensure the long-term sustainability of community initiatives, it is important to mobilize local resources by fostering relationships and communication between non-governmental organizations, local community initiatives, and local supporters. Future support is more likely. These supporters, as members of the community with a vested interest in the success of community projects, are more likely to continue their support compared to external donors. Independence by raising resources locally. An NGO or local community initiatives can gain more independence and flexibility to address the needs of a community. This also means that the organization can focus on programs that align with local priorities rather than adapting to the demands of external donors. Local support is crucial in achieving these goals. Waste stream management. Keeping track of your waste is important when trying to improve your sustainability and decrease the environmental impact of your business. The journey that waste takes is known as a waste stream. A waste stream is defined as the flow of waste from its source to its end. This destination can be the recovery, recycling, or ultimate disposal of the waste. There are two main types of waste streams: materials such as metals and glass, and products such as electronic waste and packaging. Material waste streams. Material waste streams are comprised of the raw materials involved in products. The primary material waste streams are glass, metals, plastic, paper and cardboard, wood and bio-waste. Each material has its own specific treatment and journey, and following the waste stream from source to end can help in the formulation of good waste management techniques to ensure that as little as possible is lost along the way. Metal. The two categories for metal waste is ferrous, steel and iron, and non-ferrous, aluminum, copper, and others. Waste can also contain metals from both categories and will take extra care to process. Due to the infinitely recyclable nature of metals, they can undergo end-of-waste categorization. They are then classed as secondary raw materials and can be put to further use. Ferrous waste primarily comes from the vehicle scrap and industry, while non-ferrous metals are nearly all from industry except for aluminum, which is most frequently used for packaging. Recycling metals can deliver significant energy and cost savings. Electric arc furnaces use scrap metal almost exclusively to produce steel and are much more efficient than converting from iron one. While metal can, in theory, be recycled forever, in practice it has a limit. This is caused by mixing in of other metals that have been used as coating or alloys. Good waste management practices can result in the effect of this being lessened or removed entirely. Plastic. There are over 1,000 types of plastic, but they can be broken down into three categories. Thermosets, hard plastics used when durability is needed, for example, cars. Elastomers, soft, rubbery plastics. Thermoplastics, easily moldable, used for packaging. Product waste streams. Product waste streams start with a base product that can contain many different types of material. The main sources for product waste are packaging, such as for retail and transportation, electronics like TVs and phones, batteries, mining and demolition, construction. Packaging. Product packaging is made up of many of the categories from material waste, paper or cardboard, glass, plastic, wood, and metal. While most packaging is recycled, there are variations based on the specific material used. For example, paper and cardboard used in packaging are recycled nearly 3 times as frequently as plastics. Measures should be taken to prevent packaging waste and to develop packaging reuse systems. This can be done by businesses and consumers alike, either by focusing on making sustainable packaging or by using a good waste management system to ensure it is properly disposed of. Electronics. Electrical and electronic waste, also referred to as e-waste, is perhaps the fastest growing waste stream. Nearly half of all e-waste is comprised of household appliances like washing machines and microwaves. IT equipment makes up a sizable proportion as well, matched by the waste of consumer equipment like TVs and stereos. While there is a sizable amount of recycled e-waste, a good proportion of it disappears. This lost material is either being kept inside people's homes, collected outside of the regular channels, or sent straight to landfill alongside ordinary waste. Construction and demolition. Waste from construction and demolition can contain heavy minerals, which can pose significant risk for health and environment, and is obtained from buildings, roads, and upkeep. It can contain a vast variety of materials from soil and stone to solvents and absorbents, and asbestos. While most of these can be easily recycled, some of them are hazardous, so care must be taken to separate them out during the waste stream process. The waste that results from these industries has a variety of uses, from backfilling drains and quarries to the production of made ground. It is a highly recyclable source of waste, but great care must be taken to make sure toxic or dangerous components are removed beforehand. Batteries. Batteries are made up of a variety of metals and chemicals depending on their type. They need to be sorted at the start of the waste stream, as each needs a specific process. Batteries not collected and sorted will enter conventional waste streams, which end at either a landfill or an incineration facility. While there are rules limiting the quantity of hazardous materials presented in batteries like mercury, they still need to follow special rules for their collection, recycling, and disposal. While collection rates for batteries from vehicles and industry are high, many commercially used portable batteries leave the waste stream and are lost to poor waste management like landfill and incineration. Other types of waste streams. There are another types of waste streams: municipal solid waste, liquid waste, and hazardous waste. Within this, there are subcategories of waste and various smaller waste streams. Some waste streams can overlap, such as when handling hazardous liquid waste. Municipal solid waste. Municipal solid waste is the waste stream that everyone participates in. It refers to waste that comes from households and residential communities and eventually goes to a waste management plant or whatever destination is designed in that specific community. The waste within this stream is extremely diverse, ranging from recycled newspaper to old electronics. These diverse types of waste within this large stream create smaller stream paths. While they could all go to the same waste management plant and end up in a landfill together, it's better than each type of waste create a specific stream path. This way, people can recover or recycle some types of waste, such as glass, bottles, and prevent them from wasting space in a landfill. Liquid waste. Unlike the types of waste we mentioned before, liquid waste can come from various sources. Therefore, we use the state of the matter to define this waste stream, not its source. Overall, there are three main types of liquid waste: sewage, trade waste, and hazardous liquid waste. Sewage waste refers to the liquid waste that comes from toilets and sinks of residents and businesses. Once you finish a toilet or run water in a sink, the liquid waste goes through tubes to reach a water treatment facility. That facility then cleans and filters the water so people can use it again. Trade waste is liquid waste from a business that enters the sewage system in that area. However, trade waste comes from something other than toilets and sinks. For example, when a restaurant cleans its kitchen floors with soap and water, that dirty water is put down a drain into a sewer system. Before it reaches the sewer system, though, it goes through filters to remove the excess contaminants and chemicals. After going through those filters, it continues to the appropriate water treatment facility. Hazardous liquid wastes, such as certain solvents and paints, is carefully stored in appropriate containers. A hazardous waste management company would then pick up and transport the containers to a disposal facility, which is most commonly a landfill. Many landfills have a specific area for hazardous liquid waste to protect the surrounding communities and environment. Hazardous waste. Hazardous waste can come from any source, so this waste stream is also harder to define. For example, hospitals can create hazardous waste with cancer treatment drugs. Also, paint from retail stores is often considered hazardous. However, regardless of the source, hazardous waste is stored in containers and facilities that prevent it from hurting the surrounding areas. A waste management company that's trained to handle hazardous waste will collect the containers and dispose of the waste in an appropriate manner. Additionally, the disposal method at the end of the stream can vary depending on what hazardous characteristics the waste possesses. For example, you can dispose of some ignitable waste in a landfill, but most local governments require that you dispose of toxic waste, such as chemicals waste, through an environmental health and safety office. Green infrastructure. Green infrastructure has been defined as a strategically planned network of natural and semi-natural areas with other environmental factors designed and managed to deliver a wide range of ecosystem services while also enhancing biodiversity. Such services include, for example, water purification, improving air quality, providing space for recreation, as well as helping with climate migration and adaptation. This network of green land and blue water spaces improves the quality of the environment, the condition and connectivity of natural areas, as well as improving citizens' health and quality of life. Developing green infrastructure can also support a green economy and create job opportunities. Green structure elements can be woven into a community at several scales. Examples at the urban scale could include a rain barrel up against a house, a row of trees along a major city street, or greening an alleyway. Along with reducing neighborhood flooding and pollution in our creeks and rivers, green infrastructure benefits include reducing the heat island effect, improving human health, creating or preserving valuable wildlife habitat, including for monarchs, bees, and other pollinators essential to our human food supply. How to improve green infrastructure? This can include conserving, restoring, or enhancing natural areas while incorporating trees, rain gardens, vegetated roofs, and other practices that mimic natural systems into developed areas to manage rainwater where it falls. Green infrastructure can help replenish groundwater reserves, relieving stress on local water supplies and reducing the need to import potable water, reduce urban heat island effect by planting trees and building green roofs, lower building energy demands by reducing indoor temperatures and shading building surfaces. Green infrastructure reduces and treats stormwater at its source while delivering other environmental, social, and economic benefits. Green infrastructure can be a cost-effective approach to improve water quality and help communities stretch their infrastructure investments further by providing multiple environmental, economic, and community benefits, also known as the triple bottom line.